So the starting point of what I will be talking about is work of Nies, Segal and Tent that was started here in the previous conference. And this work is about finite axiomatizability of profinite groups. So which profinite groups can be axiomatized by one single first-order sentence. And among the classes that are under consideration in this work, there are p-adic analytic pro-P groups, this class that I would call CP. And there are already in this work remarks about one invariant of these groups, namely the rank, that I will not talk about today. But this remark led to the question whether this invariant can be axiomatized by one first-order sentence, and so in my PhD I started to work on this question. So I started to work on the definability of invariants of p-adic analytic pro-P groups, namely the rank and the dimension, that is an invariant related, as I will explain in a moment. So in the first minutes, I would like to introduce the groups under consideration, namely R-analytic groups. Indeed, p-adic analytic pro-P groups are a special case of R-analytic groups, where R is a pro-P domain. A pro-P domain has a quite involved definition, so I will not write it down. This is a Noetherian integral domain that is local, complete with respect to the topology induced by the maximal idea, and whose residue field is finite of characteristic P. So I will not write all of this down. I will rather give examples that we can keep in mind, namely the p-adic integers. Set P is an example of pro-P domain. More generally, power series over set P. And power series over the finite field Fp. So these examples are actually quite characteristic examples, as by Cohen structure theorem, every pro-P domain contains a ring, a subring of this form. So of the second kind, if the characteristic is 0, of the third kind, if the characteristic is 2. So we can really think of these rings as examples. With these rings, similar to what is done in the real and complex case, one can define R manifold. So, R manifolds. Indeed, there are concepts of analytic functions and charts and atlases, as in the real and complex case, and this is the usual definition. And so the next step is to define a Lie group over these rings, so what we call an R-analytic group. This is a topological group that has an R-analytic manifold structure, and such that multiplication and inversion are analytic maps, as in the usual definitions. There are, so associated to these groups, there is a natural notion of dimension associated to, because they are manifolds. So we have a natural notion of dimension. And before talking about the finite axiomatizability of the dimension, I want to mention a special subclass of R-analytic groups, so that I can also give some examples. These are the so-called R-standard groups. The underlying set of these groups is a power of the maximal idea of R, so this M is the maximal ideal of R. N is some power that is called the level of the group, and D, the number of copies, is called the dimension of the group. And so this is the underlying set of the group. The group operation is also very nice because it can be expressed in terms of formal group laws. So an example of a standard group is given by the power of the ideal pt to the n, and then the copies of this with, for example, the abelian formal group. And this is an example of ZPT standard group. And actually, every R-analytic group is virtually in R standard group. So these are actually very important subgroups of these R-analytic groups. And now, up to the definability of the dimension. So we said the dimension is the dimension as a manifold. The first case that I want to talk about is when R is the ring of p-adic integers. In this case, an R-analytic propy group is a p-adic analytic propy group. So here we find that the class that I talked about at the beginning. And in this case, I proved in my PhD thesis, and it is published 24, joint work with my advisor Benjamin Klopsch, that the dimension of p-adic analytic propy group is indeed finite axiomatizable in the language of groups. So we can find a first order sentence that depends on P, on the dimension D, and on this other invariant that I mentioned at the beginning, the rank. And this is a sentence in the language of groups, such that given any propy group G of rank R, the dimension of G is D if and only if G satisfies such sentence. And we actually proved that also the rank itself is finite axiomatizable in the language of groups. Okay, and so now in joint work in progress with Andoni Zozaya, we are extending this to R-analytic groups, to more general R-analytic groups. So R general propy domain. And here there are two directions that we are taking, because in general it is not possible to define the dimension for general R-analytic groups in the language of groups, because there are examples of analytic groups that are isomorphic as abstract groups but have different dimensions. So we have two directions. One direction is to restrict to finitely generated R-analytic groups, because in this case we have some partial results for which the dimension is indeed definable in the language of groups, and we believe that we can extend this to a rather large class of finitely generated R-analytic groups. And the second direction is actually to extend the language in a meaningful and minimal way, so that the dimension will be definable in this, let's say, analytic expansion of the language. I will just say really a couple of words on the first direction. For finitely generated R-analytic groups, we also have to distinguish different cases depending on the ring. So here the properties of the ring really play a role. For example, we need to distinguish the characteristic of the ring, and also within, for example, characteristic 0, we regard the regular case and irregular case in distinct cases. So I just give one result as an example of what we are doing. And so it is is 25 plus, so this is in progress. If R has characteristic 0 and has some technical conditions, so it is regular and unramified, then finitely generated are standard groups, have definable dimension, or even finite mathematical dimension in the language of groups. And let me just say that this technical condition, regular and unramified, for example, this class of rings contains ZPT, so the power series with coefficient ZP, and all rings of the form lambda T, where lambda is a nice extension of ZP, so it already contains a large class of rings. And yes, so from, let's say, we are working on results on standard groups first, and we plan to extend them to R-analytic groups by using the finite index of these standard groups in the general R-analytic groups. So this is everything I wanted to say. Thank you very much.